think back to our videos in section 6.3 on disks and washers, you know that usually we're doing that if we're rotating around the x-axis, but we did do one example in which we were rotating around the y-axis, and we're able to use disks and washers in that case as well. So for cylindrical shells, we're usually using those if we're rotating around the y-axis or some other horizontal axis, but we can, in fact, use it if we want to if we're rotating around the x-axis. So in the kind of the secondary case in section 6.3, we end up integrating with respect to y, and we'll see in this case as well, we'll end up integrating with respect to y. So use the method of cylindrical shells to compute the volume V, obtained by rotating the region in the first quadrant under y is equal to 9 minus x squared about the x-axis. Okay, so what is going on here? So 9 minus x squared. So here is y is equal to 9 minus x squared. And we want the region in the first quadrant. So this is the region that we are rotating. We're rotating around the x-axis. And we're specifically told to use shells here. And so the most natural thing for us to do would just be to take slices in this direction, but that would lead to a solution by disks and washers, which would be completely fine, except that we're specifically told in this problem to use the method of cylindrical shells. So instead, we need to take horizontal slices. By the way, I think earlier in the video I said I referred to this as a horizontal axis. Of course, this is a vertical axis. My apologies. But here we're taking horizontal slices here. So if y is equal to 9 minus x squared, we want to solve this for x in terms of y, and we would get x squared is equal to 9 minus y, or x is equal to square root of 9 minus y. Everything over here is positive, so we take the positive square root. And then what are allowable y values? Well, y here is 0. Up here, y is 9. And so we are going to use our setup here. So the volume is 2 pi times the integral from 0 to 9 times the radius. And the radius here is y. We put in a y instead of an x. And then multiplied by this height here, square root of 9 minus y. So this is the setup for the calculation that we have to do in this problem. Okay, so we have to find the antiderivative of 9 times the square root of 9 minus y. The best way to do this is by substituting in. We don't like that 9 minus y under the square root, so u is equal to 9 minus y. du is equal to negative dy. And so we end up with minus 2 pi. When y is 0, u is 9. When y is 9, u is 0. And y ends up as 9 minus u. Minus sign, and we can flip those bounds back. 2 pi integral 0 to 9 of, expanding this out, 9 times u to the 1/2 power minus u to the 3/2 power du, and this is 2 pi times 6u to the 3/2 minus 2/5 u to the 5/2, plug in 0 and 9, and this gives a final answer of 648 over 5 pi. So I thought this was a good little example to work through, just to point out that even though that we usually use cylindrical shells when we're rotating around the y-axis, we can use it if we're rotating around the x-axis. The the cost, if you will. The cost is that we integrate with respect to y instead of integrating with respect to x as we're used to doing.